Hi, everyone. Welcome to a beginner's tour through virtual environments and conda environments. My name is Matt Harrison, and I'm happy to be here with you. A little bit about me. I run a company called Metasnake. Metasnake does corporate training and consulting. I've authored many books. I'll just show some of them. Machine learning, pocket reference, that's probably one that you're familiar with. Pandas 1.0 cookbook, Illustrated Guide to Python 3. And I also do a bunch of consulting as well. And so this experience of this class is from my experience teaching and training a bunch of people using these tools at big companies, small companies, online events, etc. If you're curious to follow me or contact me, I'd encourage any discussion that you might have using Twitter. My hashtag is down there, or not my hashtag, my username, __M_Harrison__Dunder_M_Harrison. So Metasnake does corporate training and consulting. I teach big groups how to use Python in virtual environments. No pun intended. I also, until recently, did a bunch of live training. Hopefully that will start up again soon next year. And so these are the topics I talk about. And so again, my experience for this class is from training thousands of people using these tools in corporate training events. So here's the outline of what we're going to cover. We're going to talk about conda. Then we'll show all of the options for conda, how to create environments, install packages, etc., pin packages. We'll do something similar for pip, talk about the pros and cons, and then I've got some labs. I encourage you to try the labs on your own. I'll also include video of me solving the labs. And I always say this in all my classes that have labs. The best way for you to learn is to try it out and get practice. So if you've never done these sorts of things before, trying it out is going to be the best thing for you to do. And so don't watch the solution until you try it out. You're going to learn better that way. That's what the science tells us, at least. And I've got a disclaimer, like, I realize that how you set up your environment is something that people are very sensitive to. And I mean, I've run across that in Twitter and other places. And so your mileage may vary. You may not like the tools or things that I'm recommending. And so if that's the case, that's great. If you want to discuss that, we can discuss things, or I'm totally open to better options as well. So again, reach out to me on Twitter and let's talk about it. Okay, so installing these tools. Again, I teach a bunch of people, and installing tends to be a pain. It's kind of annoying when you're going in for training. You spend the first, however many minutes not talking about the tools, but getting people's environment set up. So I realize, like, the purpose of these tools is to sort of breeze over that and make this less of a pain. Having said that, there's still some installation required. I'm linked to a blog post here from my website that talks about installing and setting up virtual environments in both conda and pip. And so I'll sort of leave that there as it is. Installation is pretty straightforward on most of these platforms. The one thing you need to be aware of, just if you're installing Python using Windows, is whether you've got the path environment set up correctly. And I'll talk about that a little bit more. So first of all, why environments? And again, I realize that a lot of my audience aren't software developers. They don't want to be software developers. They just want to do analysis or make visualizations or make machine learning models and sort of let the tools get out of their way. And so sometimes, having to use like Git or do software development or, create environments, these are things that kind of bother them. And so let me maybe give a reason for why you might want to do this. Say you're working on, and it all comes more from like a data science point of view, but it applies to software engineering with Python in general. Say you're working on an analysis project for your company, and you've got some pipeline. It's been developed for a couple of years now. Maybe it's using pandas and scikit-learn. It's not using the latest and greatest versions of these packages, but it's in production. It's robust. It does what it needs to do. And say that you're working on these and you installed them in your system Python. So your system Python, if you're on a Unix system, Mac and Linux, they ship with Python. If you're on Windows, then you went out and installed Python, and then you just installed these libraries into your system Python. If you did that, it might work okay. Now, the issue is when your boss comes to you and says, hey, I need you to work on a new project. And you're like, awesome. We were using an old version of pandas, and I want to take advantage of these new features. And I also want to use whatever new scikit-learn features as well. So you go out and in your system Python, you install the new version of pandas, you install the new version of scikit-learn, and you're off and running with your new project. Inevitably, your boss is going to come back to you and say, you know what, you've got to fix a bug in the old project. And so the hassle here is really, if you were to go back to your old project and it was based on older versions of the libraries, most likely wouldn't work or might have some issues. And then you'd have to go through this silly dance of uninstalling packages and making sure that the correct dependencies are installed. And that's, I mean, you can do that, but it's sort of a pain. And then you might have newer versions of some libraries and older versions of some libraries. And so to mitigate that, what we do is we use these things called virtual environments. And so what I would do when I would start this original project, I would create a virtual environment. And a virtual environment is like a sandboxed environment. I'm saying virtual environment. That applies also to conda environments as well. These are basically per project in sandboxed environments that contain the Python runtime. In the case of conda, it contains other runtimes as well. And then you install your dependencies into this sandbox. And so when you need to work on this project, you go into the sandbox, you activate it, and then you have access to the libraries in the sandbox. When you need to use a different project, you make a new sandbox for that different project, and you activate it, and you have access to libraries of those sandboxes. So you're not doing this uninstall, reinstall dance. You're just going into the directory where you have this library or this project installed, activating the environment, and you have access to it. So that's the reason for using these. I guess other reasons would be reproducibility. So if you're a scientist, it's super annoying if someone publishes some results and you can't reproduce them. It's especially annoying if they have code and you can't even run their code. And so being able to take someone's code and running it is pretty good. Ease of use. Yeah. So like from my point of view, teaching people how to use Python or machine learning or pandas, it's kind of annoying if stuff works on the instructor's machine and doesn't work on your machine. So getting people's environments set up quickly is kind of nice, and making sure that it will work with their system. So having specific versions of packages. Not messing up the system Python. So if you, like I said, if you're on a Unix systems ship with Python. Linux in particular might use the system Python for running a couple of utilities that the system depends on. So you kind of don't want to touch that. And if you mess that up, that can be disastrous. So it's best just to leave system Python sort of on its own, not install a bunch of packages in there, and then work in these virtual environments. And then again, not mess up other projects. I do consulting, so I've got tons of different projects and whatnot, and people have different requirements and needs. Someone might want me to do something with Flask, someone else using Django or a different database. And so I can just make a per project environment and have all their dependencies in it. When I need to work on that client stuff, I just go in there and activate it, and I'm good to go. I don't have to worry about installing, uninstalling, any of that. Okay, so we're going to start off talking about Anaconda. And so what is Anaconda? Just give a brief background. Anaconda is kind of, naming is confusing for computer scientists, and Anaconda might be a confusing name. So Anaconda is sort of two things. It's a company that makes Anaconda the tool. Anaconda the tool is what I would call meta distribution of Python. It's it kind of gets around what I was complaining about earlier. When I go in to teach a large group Python and they have to get Python installed, that can be somewhat of a pain. Traditionally, what's been most painful is on the Windows platform, especially with these scientific libraries. A lot of them are built on top of Fortran or C or C++. And in order to build these from source, you need to have a compiler suite installed. And a lot of people who are scientists in Windows don't have Visual Studio or whatnot installed. So it's kind of annoying to have to take half a day to install that. So Anaconda instead just says, we're going to pre-compile these and give you a bunch of binaries that work out of the box. In addition, we're going to give you a bunch of other infrastructure packages or libraries that are very popular and pre-compile those. And so it just works. You just install this big package and it just works. And they make that Anaconda meta distribution available on Windows, Linux, and Mac as well. So it's free. You can use it for free. You can also buy support for it if you're someone who needs support, that sort of thing. So in installing Anaconda, let me just say, before I get to installing, let me say a couple other things on there. So there's Anaconda, the company. They make a distribution called Anaconda. Inside of Anaconda, there's a tool called Conda. The Conda tool is a command line tool for managing environments in Conda and installing packages in Conda. Now, there's an Anaconda distribution. There's also a distribution called Mini Conda. So let me just talk briefly about the difference between those as well. Anaconda, the distribution is, I think, 600, 700 megabytes of precompiled packages. Mini Conda is more of a lean and mean version. It ships Conda and then you fetch on demand the packages that you need rather than pulling them ahead of time. They both give you access to Conda. One just has to download stuff ahead of time. The other downloads it later. So in the end, depending on if you have internet access, they shouldn't really be different. But, a lot of my clients are, inside of firewalls or whatnot, so they don't really have internet access. And so Anaconda or Mini Conda one might be better for you or the other. The tools, the commands that you run are actually the same. It's this Conda command. So you can install either one of those. So installation on Windows, there's an executable that you download and install. And then after you've installed that, you can launch an Anaconda prompt. And so if you're on Mac or Linux, instead of an executable, you download this script and you execute it from a terminal. It'll ask you some questions and then you'll restart your terminal after you've answered them and you'll have access to Conda from the terminal. Now, do you have to use this Anaconda prompt? Can you just use the command prompt? I found that it's easiest just to use the Anaconda prompt. It launches a command prompt and you can do everything from there. If you're familiar with PowerShell, there's also an Anaconda PowerShell. I don't use PowerShell, so I can't say much more than that. Okay, so once you've installed Conda, you've now got Conda installed. Conda, again, is this tool that came with either Anaconda or Mini Conda. You want to create an environment. And so Anaconda calls them environments, which are slightly different than virtual environments, which we'll talk about in a minute. But if you sort of squint or from the 10,000 foot point of view, they're very similar. So when you've got this Anaconda installed, what's an environment and what do you do with it? Well, again, an environment is a sandbox installation. Typically, I would advise making these on a per project basis. And basically, the process that you want to do is you want to create the environment and then you activate it. And what do I mean by activate? Activate means basically it's shimming into the path variable. Most operating systems have a path variable, at least the operating systems that we're worried about for the purpose of this class. And it shims into that path variable, the path to when you run commands from the command line or the command prompt or the Anaconda prompt to run the Python that's in your environment rather than the system Python. And then you just do your work in your environment, where your work in the environment is installing packages. So how do you create an environment using conda? It's pretty straightforward. You say conda create. And here I've got an example of the command that you would run. And again, I'm running this either from the Anaconda prompt in Windows or a terminal on a Mac machine or a Linux machine. And the same command will work in either place. So I'm going to say conda create and then -n. I'll give it the name of the environment. In this case, I'm saying in my slide env name. I don't know that that's a great environment name, but you might want to name it like project, whatever, your super classified project, or test environment or production environment. And then I've got Python is equal to 3.7. So what I'm doing there is I'm saying create the environment and also specify Python version. Now, this is one of the places where Anaconda is different from virtual environments. When you're using a virtual environment, you're using the Python version that's installed with it, whereas Anaconda has the ability to install different versions of Python in your environment. So if you wanted to use Python 3.6 for some reason, you say your library didn't work with Python 3.7, or you want to work with the latest and greatest 3.8, you could do that using Anaconda. So this is one of the differences between Anaconda and pip or virtual environments. Now, just an aside, you might want to get some help. So how to get help? Most of the commands have a help option from the command line. So if I wanted to get help for the create command, I could say conda create -- help, and that's going to give me a bunch of output for getting help. Now, the last command was help for conda create. There's also, you can just say conda help, and it will list a bunch of commands that you can do from within conda as well. So I'm not going to go over all the commands in there. We'll go over some of them. Again, this is a beginner's tour, but there are a bunch of commands in there that you can go over. And then you can sort of do the same thing. There's these sub commands, and then on the sub command, you can do a -- help on the sub command and get the help for that as well. Okay, so after you've created your environment, you might want to list what environments you have available. So this is an example of running it maybe on my machine. Conda is going to ship with what's called the base environment. That's like the system Python that it ships with. And then in this case, I have another environment that I've made called ML Pocket env, and you can see that it's located in this mini conda directory. So apparently I installed it from miniconda. If I install it from Anaconda, it would just say Anaconda. But Anaconda is generally going to it's going to install itself into your home environment or your home directory, and it will make an Anaconda or miniconda directory, and then it will put things inside of that. Now, another thing to note from this command, you might not see it. There's a little asterisk there. The asterisk indicates which environment is active. So if I were to run Python from my terminal or Anaconda prompt here, because there's the asterisk next to the base, it's going to run the base or the system Python. Okay, at this point, I just want to bring up a question that I sometimes get. Again, a lot of people who I deal with, don't want to be programmers. They want to use the tools to run their analysis or whatnot. And so the question, can't I just do this from a GUI? Anaconda does ship with a GUI that allows you to do some things. However, I don't use it, and I don't really recommend you use it. Not that I have anything against their GUI per se, but a couple reasons why. One is just for a better mental model for you to understand what's going on. I think it's better to understand how to do things from the command line. The GUI is going to be a wrapper from that. If you don't understand that, everything's going to be sort of opaque and just magical things are happening. So I recommend at least once doing it from the command line so you understand what's going on. But I think there's more value than just doing it once. The truth is that if you are serious about using Python to do data analytics or machine learning or make websites, you're going to have to be comfortable from the command line, like it or not, because there's a bunch of tools that run in the command line. And so while you can do this from the GUI, I'm not going to talk at all about the GUI here. And I don't, like I said, I don't use the GUI. It turns out that's going to be faster from the command line as well. And you've also got bonuses like you can script it and whatnot as well. So another thing is when you get into virtual environments, your GUI may or may not have the ability to run code from an environment or a virtual environment. So just be aware of that. If you're running it from the command line, you know what environment you're in, and you basically know that you'll have access to these libraries. Versus running from a GUI, you may have to sort of activate something from inside a GUI. Like if I'm using PyCharm, I have to activate, or I have to tell what virtual environment or conda environment I'm using inside of my project in PyCharm, right? And so if your tool doesn't have the ability to specify the environment, you might be limited, or you might not even be able to use it. Okay, at this point, you've made an environment. The next step then is to activate the environment. So to activate an environment, what you do is you run the command conda activate and then the name of the environment. You recall a couple slides ago, I made an environment called env name. At this point, I can say conda activate env name. One thing you'll notice after you run this is that your command prompt should change, and it should have in parentheses the name of the environment in there. That way you'll know that you're in the environment. You'll see it in the lab when I demo that my prompt changes. At this point, you could also say like which Python, if you're on a Unix system, and that says if you execute the Python command, which Python is going to run, and it should say a Python that's inside of your environment, which is a bash command that doesn't exist on Windows. So you'd say where Python if you want to do something similar on Windows, just to get the peace of mind that you're using the right Python. After you've activated your environment, you'll want to do the work, right? And so in this case, the work is just installing the packages that you need. So to install packages that you need, you're going to say conda install and then the name of the package. Again, if you want help for how to use install, you can say conda install -- help and get that help documentation for that. If I wanted to install the pandas package, I'd run this command right here, conda install pandas. What that's going to do is it's going to say, okay, conda, go out and in the case of Anaconda, it should have downloaded a bunch of packages. Pandas should be one of those. And it will say, okay, here's the package that you want, and I'll install that. And it should be a sudo up-to-date package per se. Now, your packages might be old. Maybe you installed Conda a year ago or something. If you want to update them, you can say conda update pandas, and then it will go out and try and update it to a newer package as well. If you want to list what packages you have installed, you can say conda list. This will list all the packages that are in your environment. Now, one thing I didn't say is when you say conda install pandas, pandas has dependencies. And so conda is going to go out and it's going to fetch any dependencies that it has. This is one of the differences between conda and pip. Conda has what it calls the SAT dependency solver. So I'm not really going to get into what SAT is, but the basic gist of it is that it goes out, and when you say install these tools or install these libraries, it's going to go out and check all the dependencies and make sure that it can install them in one fell swoop per se. The current version of the pip installer is a little bit less sophisticated. It just cycles through the packages that you want to install and recursively pulls their dependencies, but doesn't do any like global dependency checking to make sure that there aren't mismatches between them. Newer versions of pip have a new dependency solver that should do this, but the current version does not as of, what are we? We're in September 2020. Okay, if you want to remove a package, you can remove a package as well. You can say conda remove pandas, and that will remove the pandas package. If you want to install a specific package, you can do that as well. Why might you want to install a specific package? Well, if you're working with a colleague or you're working with someone else's project, they might use specific features from a specific library. And so likewise, you don't want to use newer features than what the package or the library is using. And so this allows you to say, okay, let's coalesce on the same libraries, so we're using the same feature set, so we don't have mismatches or version mismatches or whatnot. And so you can just say, I want to install pandas 1.0.1, and you put pandas equals 1.0.1, and you get that version of pandas if conda can install it with the dependencies correctly. Okay, another thing you might want to do is you might want to pin a version. And what do I mean by pinning a version? Well, the notion here is similar to what we just did in the previous slide where we specified a version, but you might want to say, okay, I don't just want a single package with a single version, but I want multiple packages, and I want to specify all their versions, right? And this is what, if you've got something bigger project that you're working on, you might be using, 20 different libraries. You might want to specify all of those versions and make sure that you have those right versions and that they're working correctly together. So the process of doing this is a little bit different. What you'll do is inside of your Anaconda or your mini conda directory, you'll make a directory called conda meta. And then inside of there, you'll make a file called pinned. And in the pinned file, you'll just put the packages that you want with their specific versions. And so if you want pandas 1.0.1, you would say pandas equals 1.0.1. If you wanted Seaborn 0.10 and then any minor version after that, or I guess that's not a minor version, that's whatever the sub-minor version is, you could use an asterisk there and say, as long as it starts with 0.10, I'm good, and it will sort of pull the latest of the 0.10 line. Let's talk about dealing with missing packages. This is something that you might run into. Now, there's in Python, we have a thing called the Python package index. That's PYPI. Sometimes people call that the PyPI, pypi.org, Python package index. And there's over 250,000 packages on the Python package index. That's one of the awesome things about using Python. Now, Conda, or Anaconda, the distribution, does not ship with 250,000 packages. It ships with sort of a handful of, here's the Pareto, you're going to get 80% with this small 20%. I mean, it's not 20% of 250,000. It's I believe less than 1,000 packages that Conda ships with. And so these are the sort of standard packages that data scientists or analysts or people doing, numeric computing will be using in the Python realm. So it might not have every package you want or the latest and greatest of the package you want. So let's talk about what you might want to do in those cases. And there is a website called condaforge.org. And that website is, how do I explain it? Conda has a notion of channels. And if you're familiar with like Linux repositories, it's sort of similar to Linux repositories where there's an official channel where you pull packages from. And so Conda has their official channel. And then there's this CondaForge, which is I don't think it's third party, but it's their community packages. And so this is something where people from the community can post their packages up there. They're not necessarily vetted by Conda per se, but you have access to them and you can install them using the Conda tooling there. Okay, so if you had a package that for some reason is not included in the base Anaconda distribution, first thing to do is search on CondaForge for that package. Now, if it's not there, then you've got a couple options. One might be that you might have an internal library that you want, and you might want to put that on CondaForge, right? So you could make a Conda recipe and put that on CondaForge. And so if you wanted to do that, I've got the steps to do that here for creating a recipe. Let me just move my head so you can see that. Okay, so there's the URL for that. You can go to that and it talks about creating a recipe. If you don't want this to be in the wild, you want it to be sort of local or private. Some of my clients have that. Then you might want to make a private channel. And so here are the instructions for making a private channel. You just make a directory, and then you're going to build your package. And then you're going to put your package in this directory, and you're going to use this conda index command to make conda aware of it. And then you can say conda install. You'll note that there's a -c command after the conda install. I'm pointing it at this channel repository that I just made, and it should install it from there without having to go out to the internet to do that. You've got another option also if you have packages that aren't in Conda or in Conda Forge, or you don't want to make a Conda recipe for them, you can just use pip. So pip, Conda works with pip, and I'm going to talk about pip later, but you can use pip to install packages in there. Now, if you're using pip, in my experience, it seems to work okay. You're going to use a different resolver, right? And so the dependency management might be a little bit different. Like I said, until recently, well, current state, pip's resolver is kind of not super intelligent versus the more intelligent conda resolver for dependencies. But if you've got a pure Python package and it's not in CondaForge, I'm perfectly comfortable myself with using pip to install that package. Your mileage may vary. Okay, so I'm going to just sort of walk through an example here of a package that I use for some of my classes. It's a package that simulates riding a ski lift. And so gist of this is it simulates getting on a ski lift, getting off, and how many people got on and off, that sort of thing. And you can see there's my GitHub repo for it. It's basically a single file. And so this is not in CondaForge. If you wanted to install the ski lift package, what would you do? These slides are going to walk through what you'd want to do. So you might want to install this conda build tool. This will build conda packages. And then you'd want to check out the ski lift repo. So it's on GitHub, so you can use Git to check that out if you want to. And then after that, in order to make a recipe for conda, you need to have a SHA hash of that. So this is the command you use to create a SHA 256 hash. Use curl to pull down a zip file and then pipe it through the open SSL command. Due to the way that conda works, it likes to work off of zip files because it can ensure their integrity that way, because it can check their checksums that way. Okay, after you've got that checksum, you're going to make this meta.yaml file. This is the recipe file. It's a combination of YAML that can be scripted a little bit. So you can see in the curly braces, there's some scripting in there. But basically, I'm saying my package is ski lift. It's got some version that's I'm setting as a variable and using in other places. I've got a URL for it, and I've got that SHA 256 hash. I'm going to put that in there that I just calculated. Let me scroll down a little bit. There's a little bit more here. And so I can say, how do I build this? I just build this using Python. So it's a pure Python package, not too hard to build. Now, what requirements do I have to build it? Again, it's pure Python, so nothing too fancy. A little metadata about it, and that's this YAML file. So once I have that, sort of specifying how to build this with conda. I'm also going to need a setup.py file. So if you're not familiar with setup.py, this is the Python standard for defining how a package in Python is made. And so because I said that this file was going to be built using pip, pip will use this to build it. Let me just show you where that was. You see here, I'm using this build command right here, so python-m pip to build that. So it needs this setup.py. If you're using, if you're doing a different file where you've got dependencies on C libraries or whatnot, your mileage may vary. You might not need to have a setup.py. You might be building in a different way, right? And so if it's not pure Python, your mileage may vary here. Okay, and then after this, I'm going to pop out to my root directory here, or the checkout directory, and I'm going to say conda build ski lift, and it should understand how to go in and build it. So conda will go in and find that YAML file. That YAML file will dispatch to pip to go off and build that. And then I can say conda install. I can do like this offline and say just install it from this directory, and that should install it. So those are the steps that I would need to do if I had a project that I wanted to install that wasn't conda made. And this is a very simple pure Python package. Again, it's not touching, something that has C, C++, dependencies, something like that. So check out a different example of a recipe if you need something a little more complicated than that. Okay, now contrast that with, like I said, you can use pip inside of conda. So another option is with this package here, I could just add a setup.py, and then I could say pip install in the directory, pip install space period, and it would use pip to install inside of my conda environment. So the example of previous 5 slides, that's showing how to install it using conda. I mean, it's using pip to build it, but it's installing it using conda. So it's sort of staying in the conda realm. This is using pip to install it. I'm sort of the opinion, keep it simple. So unless you're finding that like pip is causing you problems or the dependencies aren't working when you're using pip, you might want to migrate to conda. Again, your mileage might vary or your business needs or whatnot. Okay, and then let's talk about sharing environments. What do I mean by sharing environments? Well, it might be the case that your colleague has been, working on some project, and now you're going to collaborate with them. How do you make sure that you can work together? So the first thing you do is you export this, what conda calls a spec list. There's a command called env export. So you say conda env export, and that will give you a YAML file. That YAML file has some metadata. It also has the names of the files that you have. And with that YAML file, you can now say, I want to create a new environment, or you can go to someone else's machine and you say, I want to create a new environment. And you should be able to say conda install in that new environment, the contents of the spec file. Now, somewhat hypothetical, I said you should be able to. So I've tried to do similar things on my machine. So the machine I'm showing this on is a Windows machine, but I've got Linux installed on as well. So it's not the case that if you have non-trivial packages installed that you can just take this YAML file and automatically have it work in other platforms. What I mean by platforms, I mean like going from like a Linux to a Mac or Mac to a Windows or something like this. I actually asked about this on Twitter to see what other people are using or how other people have gotten around this, and came across the same thing that I'm doing. So in order to sort of make this work, what you need to do, you can export that YAML file, that spec file, but you can try running it in your new platform. You might run into some issues where it says like you can't find this file or whatnot. What I do in that case is I just manually hand edit that file, and I might remove hashes if there are hashes in it, or some of them have specific versions or whatnot. You might need to remove those to be able to get it working per se. So it's not something that's, I guess, I'm not super thrilled that, there is some manual sort of cleaning of YAML. I don't really like to touch YAML as much as I can stay away from it. But that's how you might share a project per se. Not really the case that you would go and like zip up a environment even on like a Linux to Linux. I don't necessarily recommend like zipping up a conda environment and unzipping it somewhere else or doing that. These aren't meant to be shared that way per se. And obviously this wouldn't work in like a cross-platform way where I'm zipping up a Linux conda environment and throwing it onto a Windows machine or a Mac machine. That's not going to work. So they aren't meant to be shared that way. They're meant to sort of be created, specifying the versions of the files and whatnot. Okay, so this has been a brief introduction to conda. And now I'm going to give you some time to do the lab. Again, what I recommend for the lab is that you don't watch the video talking about the solution to the lab until you've actually done the lab. Science tells us that it's going to stick into your brain better if you try it first. And then you'll be more open to learning when you watch the solution there. So take a few minutes and work on the lab here. The lab is, so my book, Machine Learning Pocket Reference. I've got the link here to the GitHub for that. And the lab is, chapter 3 is like just an overview chapter, and all the chapters, there's notebooks for all the chapters. So your challenge, if you choose to accept it, is to create a conda environment that can run the libraries in chapter 3, and then plop open a Jupyter notebook and execute chapter 3 in that. So take some time to do that. Try out conda and see if you can get it working with conda. This should, if you can do this, this will be sort of a good review of most of what we've talked about in the conda section. Okay, so let's do the lab. The lab is create an environment to run chapter 3 from this right here. So here's chapter 3 from my book, Machine Learning Pocket Reference. And you can see that it's using like matplotlib and pandas and scikit-learn and yellowbrick. So you can just like come in here and search for all the imports. It's using pandas profiling, this janitor library, scikit-learn, XGBoost, MLExtend, scikit-learn, NumPy, and Pickle. Okay, so there's a bunch of libraries in there. What I want to do is get all of those libraries installed using conda. So first we'll create a conda environment. I'm going to say conda create, and I'll give it a name here. I'm going to call it the ML Pocket env, and I'm going to say Python is equal to 3.7. I'm using Linux on this. Note that the same commands would run on Windows. At the end here, I'll show transferring the environment over to Windows, so you can see you can do the same thing on Windows here. Okay, so it's going to ask me if I want to proceed. I'll say yes. It's going to say preparing transaction. Okay, it looks like it worked. At least we created our environment. So let's activate. You can see it says conda activate ML Pocket env. Okay, now again, one thing I noted here is that you can see that my prompt changed right here. So here it says ML Pocket env. And if I were to come over here and say which Python 3 right now it's pointing to the Python from my virtual environment. Let me just deactivate that. And I'll run the which Python. You can see that this is the base Python right here. So, okay, so now we are activated. So what I want to do is I want to install all these packages here. So I'm going to say conda install, and there are a bunch of them. So I had NumPy in there, I had sklearn, I had MLExtend, I had XGBoost, I had this janitor library, I had pandas profiling, I had yellow brick, I had pandas, I had matplotlib, and I had Jupyter. I need Jupyter Notebook because I need to run this in a notebook. So we'll just run that. Okay, and it looks like it failed here. It says the package is not found error. So the following packages were not available from the current channels: XGBoost, Yellowbrick, Pandas Profiling, Janitor, sklearn. So a couple things, what that might mean. It might mean that there is no package in there. It might mean that my package name is wrong. It might mean that it's not in the base channel or the Anaconda channel, but it might be in a different channel like Conda Forge. So let's just take a step at trying to figure out one of these. Let's do XGBoost here. So what I'm going to do is I'm going to do conda search, and we'll search for XGBoost. Okay, and so you can see that it looks like there is a thing called PyXGBoost GPU, there's CPU, and there's PyXGBoost. Okay, so it looks like I just named that wrong. So maybe I will change the name of that. So if I come up here, I say Py-XGBoost here. And we had a bunch of other names that weren't there again. So this is going to fail again. You can see it's only going on those channels right there. I can search for alternate channels here. So let's try like janitor. I'm going to conda search for janitor. Okay, it says it's not in there. We can do like, let's search in Conda Forge. That C should give me the channel for Conda Forge. Okay, and it looks like it's called PyJanitor, and it is in Conda Forge. So you can do something similar to for all of these other ones here. You can see that we're missing Pandas Profiling, sklearn, Yellowbrick, Janitor. So I'm not going to go through all of these here. So I believe ML Extend, I believe that's just in Conda Forge. Pandas Profiling, actually, so you can search in Conda Forge. If you can't find it there, you can also like go to their website. But Pandas Profiling, turns out that the name is not underscore profiling. That's the name of the library when you import it, but it's Pandas dash profiling. sklearn, this is the name of the library as well. So it's called scikit-learn. Yellowbrick is in Conda Forge, and we need to say PyJanitor. So I'll just sort of cut to the chase and not do that. But so I'm going to change this to scikit-learn, ML Extend, XGBoost, PyJanitor, Pandas dash profiling, and I'll say C Conda Forge here. Okay, it looks like it did work, or at least it installed. Let's go ahead and clone this repo now and see if we can run it. Come up here and I'll click on this and I'll copy that. Okay, so now I'm going to cd into ML Pocket Reference. I'm going to say Jupyter-notebook, and I'm going to say port 8889. say Jupyter dash notebook dash port 889. There we go. Okay, and I'll do localhost 8889 here. Zoom in a little bit. Okay, we'll just run all, see if that works. It's taking a while doing this pandas profile report. Trying a bunch of different models here. Doing some grid search. Some evaluation. Plotting a learning curve. Okay, so it looks like that did indeed work. Okay, what I want to do now is we've got our conda environment working on Linux. I want to export that and see if I can get it running on Windows. So let's try and do that. I'll come over to my Linux prompt or my Linux terminal. So this left one, the one on the left is Linux. It's running on the Windows subsystem for Linux, but it's Ubuntu. And then on the right, this over here is the Anaconda prompt. So again, to get that, I would come down here and come down to Anaconda and click on Anaconda prompt to get that. So first I'll list my environments, the conda env list over here. And I've got this ML Pocket M. So what I want to do is I want to export that. And I'm going to say conda env export. I can say -n here without being active in it. So I can say ML Pocket env where I could activate it. And then I'm going to put that in a spec file. So I'll put that in on my Windows machine. I'll put it in my documents directory and I'll call that mlenv.yml. Okay, so I've got that. Let me just pull that up so you can see what that looks like. Okay, so this is the file over here, and you can see that it's got at the top of it the name of the environment, the channels that we're using, and then the dependencies. If you look at the dependencies, you'll note that there's a bunch of things that I did not install. These are the recursive dependencies of what we did install. So we've got, this is 140 lines long of YAML. Okay, so what I'm going to do now is I'm going to try and load this in my, I'm going to load this into my Windows environment. I'm going to make a Windows environment and then load it in there. So let's make a Windows environment. I'm going to say conda and create, or just conda create, and I'll give it a name, and the name will be mlenv. And I will say Python is equal to 3.7. Okay, now I have the environment made. Let's try and load my environment in there. To do that, I'm going to use the command env update. So I'm going to say conda env update, and the name, which is this mlenv, and I'm going to give it a file. So I'll say -- file, and that's in documents, and it's mlenv.yml. And I need to say name here, like that. Okay, so that did not work. you'll see I got these errors, resolve package, not found issues. And so what I've found is that I need to actually go in and edit this. Like I said, I asked people on Twitter and LinkedIn what they use to do this cross-platform conda, and a lot of them said that they hand make these YAML files. So let me show you what I'm going to do here. I'm going to take my YAML file, and I'll just come in here and delete all of these. I'll leave matplotlib in there. Let's see, what else do I want? I want ML extend. We'll have notebook. Want NumPy. Pandas profiling. I want PyJanitor in there. scikit-learn. Seaborn. Yellowbrick. Okay, so now I've limited this to just these files that I want. Let's push it up the hill and see if it crashes again or what it complains about this time. It's going to complain about the versions, but we'll just let you see that that happens. Okay, so it has various versions that it cannot find here. So what I'm going to do is I'm just going to write a little macro in Emacs to get rid of the versions really quickly. Okay, and let's try it again now. Okay, it looks like that worked. Now that wasn't particularly useful because I didn't put any versions in here. So let me just undo these and let's try again, leaving the versions in there and seeing if we can make it work with the versions. I believe that thing following the second equals is some sort of hash. So let me write another macro to remove that. Okay, and let's try this again. Okay, so just for kicks, we will come over here and say conda env export and dash name ml env and whoops. And check out what is in that environment. So it looks like it has Yellowbrick, the version there. Scikit-learn. So it looks like that worked. Okay, so the takeaway from this is that you can do cross-platform conda environments. You need to export this YAML file with your files in it. You'll probably need to edit it a little bit. And again, like I said, most people that I know are hand editing these and keeping only the main projects they're requiring on in those, and then letting the dependencies come in as they are. Okay, good luck with using conda. Hopefully you were able to do something similar on your machine. Okay, we're going to talk about pip now and using virtual environments with pip. So what is pip? Pip is a recursive acronym in the classic geek tradition, stands for pip installs Python. It is a tool that is shipped with Python 3, and it gives you the ability to basically query the Python package index, that's pypi.org, for a package, download it from there, and install it. And I like to combine pip with virtual environments and make sure that I'm having an isolated virtual environment to install a package into. Like I said in the conda section, when I'm working with pip, I tend to work with virtual environments. And when I'm working with clients, I will have a project on a per project. I'll have a per project basis. I'll make a virtual environment for each project, and then I will install the dependencies for those projects in there. And then I'll show how you can freeze the packages that you installed in there and make a list of the packages so that someone else can easily come to that virtual environment and replicate it on their machine. Okay, so installation. Like I said, pip comes with Python. You should have access to it. In general, what I see is some Linux distributions you, for some reason, might not ship with pip. Most of them do, but some you might have to run an additional command to ship with pip because some Linux distributions think that people who install Python their view is that they're only going to install server-ready packages, and so installing isn't something that you should do on a server per se, and so they don't ship with tooling for installing, just tooling for runtime per se. So you might on a Linux package need to install, use whatever apt-get or RPM or whatever distro you're using. You might need to install pip if the commands that I show later don't work. The other issue that I see a lot is on Windows, and this is maybe more common. It turns out that on Windows, the installer from python.org, there's a checkbox on it that says add Python to the Python path, and add Python to the path environment variable, capital PATH, and that is not checked by default, which is sort of sad because if that's not checked when you launch a command prompt, you don't have access to Python from the command prompt. And if you watched my section on conda, you notice I had a little rant about, can I do this from a GUI? You really want, if you're working with virtual environments, you really want to do it from the command line, not a GUI. And so generally what I recommend to students is if they've installed Python and they have it installed, but they don't have access to it from the command prompt. And again, to access the command prompt, you would go to your search terminal and you'd type in CMD, and it would pop open a command prompt there. And from there, you can type Python. If it says like Python not found, probably means that you didn't check that box. So the easiest thing to do is actually do a reinstall. If you have the same installer, you can do, I believe it's called repair install. And there's a little checkbox that says like add Python to your path. And if you just click OK on everything after that and then restart your command prompt, when that's done, you should have access to Python. There's another option for installing Python on Windows. Well, I mean, there are multiple options, but another common one these days is to install Python from the Windows Store. Nicely, they have added Python to the Python path if you install it from the Windows Store. So that's a installation. Again, the virtual environments and pip ship with Python 3, so you kind of get access to them. You just need to be able to run it from the command line. Okay, the process here is very similar to what we saw with conda. Again, I'll sort of distinguish, I say environment on this side, that maybe this should be a virtual environment. So virtual environment is what we use with Python, that ships with Python. Conda doesn't call their things virtual environments, they call them conda environments. So I'll try to be somewhat pedantic about the difference between those. So we create our virtual environment, similar to a conda environment. We activate it. This is somewhat similar to conda as well. And then we work inside of that. In this case, we're going to use the pip command. And after we've activated our virtual environment, again, what activation is going to do is going to shim the binary locations of our virtual environment at the front of our path. So when we invoke Python or when we invoke pip, we're using the virtual environment Python or the virtual environment pip, and we're installing libraries into those locations. Okay, so to create an environment, this is a little bit different. So conda has the conda command. There's no, well, there is a VM command. I don't recommend using it. I recommend running it this way. And this might be a little bit weird to some of you, but it turns out that Python has an option from the command line when you're running Python, the -m option. The -m option, a lot of people aren't familiar with this. What it means is, hey, Python, when you run, I want you to go out to the places where you have libraries installed, which is called the Python path, all one word, not the system path. And these are directories where Python looks for libraries. And I want you to look for a library, but instead of loading it as a library, I want you to execute that file. And so this command here, what I've got, Python 3-m VM, that says, look for the VM module in the Python path and then execute it. And so it turns out that the VM module can be executed. And so we're running this little virtual env tool via Python 3. So, and then the jp-conv env, that's the name of the environment that we're creating. A couple more notes on this. One is I'm saying Python 3 here. Why am I saying Python 3? Well, on Unix systems, again, Python 2 is shipped with Python, so you need to install Python 3 on Unix systems. And to distinguish between Python 2 and Python 3, I write Python 3. On Windows systems, since Windows doesn't ship with Python, at least not a Python that you can access, if you install Python from python.org, you get Python executable. You don't get a Python 3. I believe with the Windows Store version, you get Python 3 and Python. So on Windows, you might need to say just Python space -m. Python 3 might work depending on how you installed Python. So I'm just going to put Python 3 here. Just be aware that on Unix systems, you need to type Python 3. On Windows, Python or Python 3. Python will probably work on Windows. Python 3 might work depending on how you installed it. So just be aware of that. Okay, a couple other things. So where to put a virtual environment? We saw that conda puts its environments in a root directory in your home directory. It just lists them out there. You can do a similar thing with virtual environments if you want to. What I tend to do is I tend to make the virtual environment in the project itself. I just make a directory called env in that project or venv in that project that has the virtual environment in it. I just make sure that I don't check it into source control. That way, the project is there right next to, or the virtual environment is right next to the project. I don't have to worry about like finding it or which virtual environment I was using. Makes it really easy to do that. There are other tools. There's a whole sort of third-party tools around pip and virtual environment that manage virtual environments and give you the ability to, say, I'm going to work on this virtual environment or list my virtual environments or whatnot. I'm not going to cover those. I don't use them personally, but some people like them. So your mileage may vary. If you've got, tools or locations that you specify in, for your conventions, for your projects about virtual environments, adopt those and use those. But all these tools are basically wrappers around pip and virtual environments. Okay, after we've created our virtual environment, we need to activate it. And this is a case where pip and virtual environment are a little bit different from conda. And conda, when you activate, you just say conda activate. On virtual environments, when you activate them, it's actually a different command for Unix systems versus Windows. And so on Unix systems, we're going to say source, and then in the environment that we just created, it will make a directory called bin, and inside that directory, there will be an activate file. But that activate file, when you say source and then the virtual environment bin activate, what it's going to do, again, it's going to shim into your path environment variable. The virtual is going to shim that bin directory where activate is, and inside of that bin directory is Python and pip as well. We'll see that in the lab when I show you the lab. I'll show you what's inside of that as well. So because source is a bash command, it's a Unix command, it won't work on Windows. So this command does not work on Windows. So if you're on Mac or Linux, you'll run this command. If you're on Windows, you'll run the command below, which is when you create a virtual environment on Windows, it doesn't make a bin directory inside the virtual environment. It makes a scripts directory because that's more Windows-esque or whatever. And inside of that, there's an activate batch file. You're just going to execute that directly. There's no source command. So you just execute that. After you run either one of these commands, you'll note that your prompt will change. And in this case, because the virtual environment is named jpconenv, your prompt will have jpconenv in parentheses there, indicating that you are indeed activated that virtual environment, and that is at the front of your path. Again, you can test that. You can say which Python, and which is a Unix command, so that will only work on Unix systems. But if you say which Python, it should say a Python from your virtual environment. And similarly, if you say where Python on Windows, it will do the same thing, whereas the Windows version of which. Okay, so after you've done this, you can just install your packages here. So I can say pip install, and I can give a list of packages, and it will go out. And what it's going to do is it's going to go out, again, current version of pip, will go out and ask PyPI, the Python package index, hey, do you have a package named this? Give me sort of the latest released version of it. And it will pull that down. Then it will look at the dependencies for that package, and it will recursively get all the dependencies. And then it will go to the next package in the list and just go through all these. Again, it doesn't sort of pull down everything and take all of the group of dependencies and figure them out. At least the current version of pip does not. The new version is supposed to have a smarter resolver that will do that, but the current version does not do that. And so it just walks through all these and installs all their dependencies and the packages themselves. Okay, if you want to update a package, maybe you installed a package and now a new version has been posted. You can say pip install -u and say the package you want to update. And then we'll go out to PyPI and see if there's a newer version that's been released, and it will update it or tell you that it can't update for whatever reason. If you want to list what packages you have installed, you can say pip freeze, and this is just going to spit out all the packages that you've installed with their corresponding versions. Typically, what you do with the output of this is you redirect it to a file, and they tend to call this a requirements file. And then once you've got that requirements file, you can sort of pass it around and use it to install packages from the requirements file. Instead of saying pip install pandas, you say pip install and you point it -r and you point it at a requirements file, and it tries to install everything from the requirements file. Maybe seems a little bit trivial now, but one of the initial reasons for creating pip was the ability to uninstall packages. So prior tooling before that didn't really support uninstalling very well. And so this was sort of a novel thing, at least in the Python world, to uninstall packages. Personally, I don't find myself uninstalling packages too much, but you can do that if you want to. And just say pip uninstall. If you want to specify a specific version of a library, you can do that as well. The Python package index, if you're registering packages there, basically every time you make a release, you would register a new package. And so if you had a specific version, Python package index would know about that version and should be able to point you to that version and give you the ability to install it. Now, again, there's this notion of pinning packages. And what does pinning mean? It means that I have a collection of dependencies or libraries that I want to use with specified versions, and I want to make sure that I use exactly those versions. And so what you do is after you have your environment set up such that you've got all the versions that you want, you can say pip freeze and redirect that to a file. And then once you have that file, like requirements.txt, you can just say pip install, and instead of saying the name of the library you want to install, you can say -r with the file, and it will go out and pull down each of those versions that you've specified. This tends to work fine. This works, in my experience, it works sort of cross-platform. Like I can make a requirements file on Windows. I can take that onto Mac or Linux, and generally it tends to work okay. I mean, there are some cases where you might have a person who has created a library, put it on PyPI, but for some reason, maybe it's not a pure Python package, but it's got dependencies, or it's wrapping something in C or Fortran or something. Maybe they only work on Linux, and so they only built a Linux version of that, so it won't work on Windows per se. But for pure Python packages, don't see a problem. And many of these other packages, popular scientific packages, pandas or whatnot, they're pre-built when they're pushed up to PyPI, so you don't really need a compiler suite for them anyway, and so they just work. Okay, so let's assume that you might have a missing package. This is maybe a little bit weird for like PyPI to have a missing package, but I've got an example here. Like my ski lift, I haven't registered it on PyPI, so maybe someone is going to go out and register it or something on there. But it's not on PyPI, right? It's just in my GitHub, and so maybe you've got some internal tool or whatnot that you need to install. How would you get that installed into a virtual environment? If you can't find it, search on PyPI. Maybe you'll find, maybe you didn't use the right name or something like that. If you've got a local library, what you can do is you can create a setup.py file. Again, I sort of walked through that in the conda section for like my ski lift. And then just change into the directory where the library is. And then you just say pip install period, and it will install that library locally. So pretty straightforward if you've got a pure Python package. If you've got something that has dependencies on C or C++ or something a little bit more involved, my recommendation there is to find a similar package that's doing build that seems to work, and just basically take their code and use their code to do something similar. So here's the ski lift example here. I'll just plop away my face so you can see the link there. So it's on GitHub. It's not on PyPI, at least I don't think it is. And so, if you wanted to have access to the ski lift code in your virtual environment, you would check out that project. You would create a setup.py file for it since it doesn't have one. And then you just, once you've got that setup.py file, you would go into the directory, and then you'd say pip install period, and it would install into your virtual environment. You should be able to say import ski lift and have access to it at that point. Sharing environments, again, I've sort of covered this before, but virtual environments and conda environments are not meant to be shared per se. They're meant to be easily recreated. And where easy might be a little bit harder in conda than I've found and experience in using virtual environments. But basically, I'm going to, once I've got a virtual environment that I like, I'm going to say pip freeze, redirect that to a file. I might go in and edit that file, right? This is going to show all of the libraries that pip has installed. I might just want sort of the root installations that I've done. I might not want all the dependencies, but I can leave the dependencies in there as well. And then I'm just going to take that file. I'm not going to copy my virtual environment over to another machine. I'm going to take that file and I'm going to create a new virtual environment and install from that file to replicate that virtual environment. My experience has been that this tends to work pretty well, and replicating a virtual environment this way tends to work pretty well, my experience. Again, your mileage may vary. Some people who are doing data science things, one of the sort of, I guess, a challenge or maybe one of the harder installations I'm finding is like GPU installations, right? Where I need like TensorFlow, and those can be a little bit more difficult, right? Where they only work with certain versions, certain libraries, and you might have to run some things by hand, and maybe pip doesn't work for certain libraries. And so those are cases where, yeah, maybe you can't use pip, maybe you can't use conda, maybe you can. You might need to sort of do your own little build automation or whatnot if you're doing this often. But for pure Python or for sort of the non-GPU stuff, I've found that both pip and conda tend to work pretty well. Okay, so that was a brief overview of virtual environments and pip. And now, again, I'm going to give you the same lab that I gave you with conda, but what I want you to do now is sort of start from scratch. And again, go to the GitHub for this book, and you can clone that. And then what we want to do is we want to see if we can get all the dependencies for chapter 3 installed using a virtual environment and using pip. So how will you know that you've done this correctly? Well, you will have created a virtual environment. You've installed the dependencies. You'll open up Jupyter with chapter 3 there, and you'll click on the command that says run all cells, and it should run all the cells and not give you like import errors or whatever. It should everything should just work. And if you've done that using only virtual environments and pip, you can give yourself a big pat on the back. Okay, so this is the solutions for the lab for using pip and conda. I will demo creating a virtual environment and then installing the libraries and running the notebook using pip. Then I'll also demo taking my pip environment and moving it from Linux to Windows. So you can see how I can take my virtual environment and transfer it from one platform to another. So on the screen here, I've got a Linux terminal. Let me just launch a Windows terminal as well. So to launch a Windows terminal, well, you can come down here and you should be able to say command here, and hopefully Python is in your path. It looks like mine is, so I'm good here. Okay, so I'm going to work with Linux first, and then I'll move it over to Windows. So let's make a virtual environment. I'm going to go in. I've already checked out the project here. So that's ML Pocket Reference. So I've git cloned this. I'm just going to make a virtual environment here. I'm going to say Python 3-mvm, and I'm just going to call it env. Okay, so that has worked. If I say which Python 3 right now, you'll note that I'm using Anaconda's Python. What I'm going to do is I'm going to activate the virtual environment which I just made. I'll say source env bin activate, and I will activate that. If I say which Python 3 now, you can see that I'm using the virtual environment that I just created. And let's install what I need from that notebook there. So let me just pull it up in a web browser. Here's the notebook. Make the font a little bit bigger. So you can see that I'm importing matplotlib, pandas, scikit-learn, yellowbrick, pandas profiling, janitor, scikit-learn, XGBoost, MLExtend, NumPy, and pickle. Okay, so I've got a list of those packages that I need, and I'm just going to first try them out. I'm going to say pip install. We'll say NumPy, sklearn, MLExtend, XGBoost, janitor, pandas underscore profiling, yellowbrick, pandas, matplotlib, and notebook, Jupyter Notebook. Okay, it looks like that finished. Let's run Jupyter Notebook and see if we can run our chapter 3. Say port 8889. I'm going to run everything. Okay, and I got an error here. XLRD is not installed. So that's my bad with my installation. We'll just say pip install XLRD. Okay, it looks like we need config parser as well from janitor. I'm going to have to because I imported janitor's in the namespace, so this is a no-op now. What I'll do is I'll reload this with the import lib to force it to reload. So import lib.reload. I'm going to reload the JN namespace. Okay, so this is actually showing an issue that's my bad here. So the janitor project, the PyJanitor project, I said pip install janitor, and I believe I need to say pip install PyJanitor. Yeah. So this is loading some other library that's not PyJanitor. And so what I'm going to do is I'm going to say pip uninstall. You see that. So presumably the new version of pip would prevent this, because what this janitor library was looking for was a Python 2 version. I'm going to say pip install PyJanitor. How did I know it's PyJanitor? I went to the website. You go to the website. It says pip install PyJanitor. Okay, cool. So let's keep going, run all below. Make sure that we don't have any more issues. Right now it's trying a bunch of different models. Okay, now it's trying to do some training of some models. Okay, that looks like it did finally work now. Awesome. So what I'm going to do is I'm going to kill my notebook here. And now I'm going to show how to transfer this over to another platform. So I'm going to transfer this from Linux to Windows, and let's see if we can make it work from Windows. I'm going to say pip freeze. And these are all the libraries that I'm using here. So I'll just say pip freeze, and I'll put that in my documents directory on my Windows machine. Call that piprec.txt. Okay, So let's try and do this from Windows. Here I am in Windows. I'm going to say python-mvm. I'm just going to make a virtual environment, env, and let's activate that. Now, before I activate that, I'll show that when I say where Python, I'm using the system Python, and after I activate it, I'm using a different Python. So where Python, and it shows that I've got multiple Pythons installed, but this is the Python 3.8. I believe I installed that from the Windows store. Let's activate this. So env, and in there will be a scripts file, and then I'll run the activate command in there. Look, you can see that my prompt has changed. If I say where Python now, I'm using that one right there. Okay, so what I'm going to do now, instead of installing everything that from the command line, I'm just going to say pip install -r requirements file, and that's going to be in documents, and that's going to be pip rec. While this is running, what I'm going to do is I'm going to copy my notebook over to my Windows machine so I can run it from Windows and just validate that it's working there. Okay, this looks like it worked. Let's launch Jupyter. Okay, and I left that in there. I shouldn't have that in there, so I'm going to delete those cells, and I'll just run it from here. Config parser is a Python 2 library running Python 3, the capital config capital parser. Okay, running the learning curve and pickle. So it looks like it should work here. Awesome. Okay, so that was our example of running our code using pip, creating a virtual environment with pip, and then sharing that virtual environment from Linux to Windows and running it to make sure that it worked. Hopefully you were able to do something similar, not cross-platform per se, but creating a virtual environment and running the code in a virtual environment. Okay, let's compare and contrast pip and conda. Like I said, your mileage may vary. This is my experience teaching many students using both tools in both live and online classes. Again, I haven't, for my classes, I haven't done a lot of like installing GPUs and getting sort of, I guess, tougher installation requirements working. I've done that on my own, but I haven't done that, with dozens or hundreds of students at a time. So here's sort of my pros and cons of both of them. Let's go with pip first. One of the nice things about pip is that it comes with Python, and I think that's nice. The out of the box experience is important. I've had people who I've interacted with in social media or whatnot. They're like, use Docker, use Docker, use Docker. And, again, most of the people I'm working with don't want to be programmers. Having to like give them a Docker introduction before talking about like basics of Python is like brain overload. And so being able to just use Python out of the box without having any dependencies is great. Now, having said that, Anaconda ships Python. And so, if you're installing Anaconda, you get Conda with it for free. There is that. The second point here is that it's faster. And admittedly, I haven't used the new dependency resolver in pip, but maybe some of that is due to, the dumb dependency resolution in pip. But pip just, tends to like go out and install these things and be done, versus a lot of times I've sat in classes where people have been like running conda for like 5 minutes on modern machines, and it just sort of thinks, versus like the similar command to use pip. And then, sometimes we just say, okay, well, let's just kill that and use pip. And, pip works in like 20 seconds or something like that. So again, does that mean that conda doesn't work? I mean, sometimes it might, but sometimes it just seems to get bogged down. And there is some advice on the conda website. It says, like, if you're installing a bunch of packages, and do them all in one fell swoop. Don't install package 1, then package 2, then package 3. Just say conda install and then list all of your packages. The next point is that there are more libraries available for pip. Again, like I said, Python package index has over 250,000 packages. That's huge. And you can take advantage of those. Okay, so again, pip, I didn't put this on the slides, but the next version of pip, or upcoming versions of pip, will include a smarter resolver that is going to be a little bit stricter. So that, that might bite some people, where they have versions of libraries that are incompatible with each other. And pip right now will just install them. For future versions of pip will sort of say, nope, you can't do that. Those versions don't work together. Okay, let's talk about conda then. Conda, one of the pros with conda is that you can manage the Python version. So pip comes with the Python version you installed. Conda ships with Python, but you can also say, I want to use Python 3.6 or 3.7 or 3.8 if you want to as well. Now, there are other Python tools that allow you to do similar things using the virtual environment collection of tools per se, but I'm not really going to go over that today. On that note, conda also manages non-Python libraries, right? So if you've got something like GraphViz or sort of C libraries under the covers, or if you needed to access like a Postgres database and you're wrapping the Postgres C libraries, right? Conda can ship with those and just give you a package that gives you access to those, a binary that's installed. You don't need to go and build it. You don't need to install the development headers, whatnot. Conda also has optimized libraries. So they use the Intel compiler, which apparently does some fancy things to do some vectorization or whatnot. That's a little bit more optimized than what you'll get out of the box with the python.org Python. So presumably, if you're using NumPy from conda, it might run a little bit faster. I haven't ever tested that per se, but so if those things are important to you, just be aware of that. It might be something that pushes you to use conda. Again, conda, as of right now, has better in that it is more correct dependency resolver, right? Where we'll look at all the packages and say, okay, I need to make sure that these all work together, or at least that their versions don't conflict per se. And with that correctness, I believe it is a source of slowness. So again, your mileage may vary whether that's important to you or not. And no Windows compiler is required. I think, this is a huge one for out-of-the-box experience. I keep saying this, but getting Windows set up traditionally has been a little bit harder. A lot of people using Linux, they already have all the compiler chains set up. People on Macs, a lot of them use Homebrew. And if you're using Homebrew, you have compiler chains set up. So it's not a big deal per se, but on Windows, kind of a pain. So this just sort of skirts that issue and lets you, okay, let's just install conda and we can start using Python. We don't need to spend half a day installing Visual Studio and associated libraries. Sharing is harder. Like I said, if you just export your files from conda and you give that to someone else, there's no guarantee that will work per se. There's also no guarantee that it will work in pip. I just found my experience, again, your mileage may vary, is that pip seems to just work with sharing requirements files more so than conda does. And then the last one, there are less libraries included in like Conda and Conda Forge, but you have access to pip, so you can pip install. And so when would I use pip? If I've got a pure Python package, I'm personally fine with using pip to install it. Your mileage may vary as well with that. Okay, so what are some other options for managing Python libraries and environments? Like I said, there are lots of tools around pip and virtual environments. Um, Virtual environment managers that stick virtual environments in certain places. There's things that are more robust with looking at hashes and making sure that versions of files are correct. So you can check those out. I'm not really going to go into them. Like I said, they're all built around virtual environments and pip. And so I think there's value in understanding on what's going on at the lower level. And then when you abstract that, you'll sort of understand what's going on with the abstractions. One thing to be aware of is this poetry tool. This is, I guess, next gen version of like setup.py. And so it's supposed to be a little bit better for packaging. And I guess the big draw there is, when you're defining runtime dependencies and build dependencies, setup.py is not very good at that. Poetry, people have thought about that a little bit more. Poetry, from that point of view, has some overlap with conda, right? The people in the conda realm are thinking about sort of these compiler chain issues with Fortran or C++. Just to sort of cast broad strokes, like people in sort of the Python realm and with like setup.py and whatnot, traditionally they've been more concerned with like pure Python. There is support for making, wrappers that wrap other languages or whatnot, but pip and virtual env are more catered towards Python, pure Python libraries, not necessarily wrapper libraries. And so I mean conda, I think that's part of the reason why conda sort of went off and made their own tooling rather than sort of reusing what was in the Python ecosystem per se, because the Python ecosystem probably didn't support it to the extent that their customers or they wanted it to. So I don't think poetry is going to replace conda per se, and I don't know that there's necessarily any will from the Anaconda people to sort of incorporate that per se, but something to be aware of. If you're coming to if you're watching this video from more of like a software development or sort of a web background than more of an analytic data science background. Another option would be leveraging cloud environments. So you've got things like AWS, which has Jupyter notebooks available on it. Colab, teach some classes where I just have students use Colab, and then we skirt all installation issues. And Colab ships with pre-installed libraries, and I just make sure that my lecturers and labs all work with the pre-installed libraries, and you're good to go. Will that work for you? It might. I mean, the other thing you can do with Colab is you can install other libraries. You can use conda or you can use pip to install other libraries, and you have access to GPUs as well. There are pluses and minuses to that, but that's another option. And then the other, maybe this is the big elephant in the room, is Docker. I will say this, I've deployed software using Docker, Python suites using Docker before. I think Docker is an okay tool for that. I mean, it's going to allow you to basically pin down exactly what you need. Is it super user-friendly? I mean, I think it's okay for developers. Like I said, a lot of my clients and a lot of the people who I'm working with don't necessarily want to learn about Docker. I mean, some of them do, and some of them use Docker, but not all of them do. They want to learn about making machine learning models or how to use Python, right? They don't want to have to care that their specific version of, pandas is exactly the same that's running on the production machine per se. I mean, yeah, you can use Docker. That's going to be a whole lecture or series of lectures on itself to sort of understand what's going on with Docker and get that up to speed, and even best practices as far as like building Python environments in Docker. I think my experience is that there's a lot of flux around that even still. So, I mean, uh, maybe it's getting a little bit better, but it, it's not something that you just run one command generally and you're good to go. You've got to understand a little bit more. So definitely an option for you. And again, if you're, I would say, if your goal is to have the exact same bits running on every machine, then Docker is probably where you want to go, because like I said, conda doesn't really give that to you. Like, you can export your file on conda with your requirements and probably won't work cross-platform. Docker, I mean, it basically abstracts Linux, and so you're running the same Linux machine cross-platform. Okay, so I hope you've enjoyed this course. It's been fun for me to teach it. I wish that I was speaking to you in person and we were doing this live, but we'll take what we can get right now. If you have questions or comments or feedback, love to hear them. Best way to reach out to me is either via Twitter, again, Dunder, M Harrison _ M Harrison __. Also available on LinkedIn as well if you want to connect with me there. Best of luck to you. Hopefully you've got some things that you learned from this class that you can leverage to have a better development environment using either Conda or virtual environment and pip. Have a great day. Thanks for watching. Bye.